to question 3. Question. Yeah, that is question 3. We see two acids reacting with iron tetrasulfate 6 and then giving us that product on the other side. Let's bring out the equation very well so that we can now balance it. Yeah, that is the equation. Now the first thing I'm going to do here is to list out the number of atoms for each element present. Now here we have H1. There's one here. There's one here that is not written. So the number of hydrogen atoms there is 1. Then the number of hydrogen atom here, nitrogen here is 1 also. The number of oxygen atoms here is 3. O3. That's why it is 3. Over here hydrogen is 2. Over here sulfur is 1. Over here oxygen is 4. Over here your iron is 1. Sulfur is 1. Oxygen is 4. You can see it O4. Iron here is 2. F2. Fe2. Then over here this is supposed to be 1. That's supposed to be 1. S1. But there is a 3 outside the bracket which applies to everything inside the bracket. So this 3 applies to S. It applies to oxygen also. So the 1 of X will multiply the 3 outside there to give you 3. Then for the oxygen we have O4, but there is a 3 outside affecting it. That's 3 times 4, making it 12. The hydrogen here is 2. The oxygen here is 1. Nitrogen here is 1. Oxygen here is 1. Okay, we now proceed by assuming coefficients for all the reactants and the products. So I'm going to put A here, I'll put B here, I'll put C here, I'll put D here, I'll put E here, and I'll put F here. Now let me start from this. You have to multiply all these numbers by their respective coefficients. Like this H now, the number of hydrogen atoms present now is 1 times A. That's A. This one is also 1 times A. That's A. 3 times A. That is 3A. Then over here 2 times B. 2 times B. That's 2B. 1 times B. That's B. 4 times B. That is 4B. 1 times C. That's C. 1 times C. That's C also. 4 times C. That's 4C. 2 times D. 2D. This is 3 times D. That is 3D. 12 times D. That is 12D. This is 2 times E. 2E. 1 times E. That's E. 1 times F. That's F. 1 times F again. That's also F. Now these are the things we have. We'll now go ahead to write the numbers of atoms for each element on both sides. Let's start with element hydrogen. Let's start with hydrogen. Now on this side hydrogen is here, hydrogen is here. We're going to add the number of atoms of hydrogens together for the reactant side. For the reactant side over here we have number of hydrogen to be A, plus over here we have 2B. So A plus 2B. Okay, let's go to the product side now. Is equal to, well, why do we have hydrogen here? Okay, hydrogen is here. Is equal to 2E. Is equal to 2E. So I think I'm done with hydrogen now. I can move on to nitrogen. So let's go to nitrogen. For nitrogen over here we have what? A. No other nitrogen on the reactant side. So for the product side, that's equal to number of hydrogen is F. Hydrogen atoms F. Let's leave nitrogen and go to oxygen. Oxygen appears in almost all the constituents, both on the, for the oxygen now. Now this oxygen here is 3A. So 3A, the one beside it, still on the reactant side, is 4B plus 4B. The oxygen here is 4C, still on the reactant side, so plus 4C is equal to, let's see the oxygen here, that's 12D. 12D. So I put 12D plus on the other side there this E plus E plus oxygen here is what? F. Right. So the number of oxygen atoms on the reactant side is equal to the number of oxygen atom on the product side. Now let's move on to with the nitrogen. Let's go to sulfur. For sulfur, we have B plus. On the reactant side, we also have C. That's equal to the sulfur here is what? 3D. Any other sulfur? None. Okay, we're done with sulfur. Let's move on to iron. Iron, Fe. The iron here is here. That is C. Is equal to what about the iron in this place? Okay, this is the only place where we have the iron. 2D. 2D. That is 2D. Good. Good. Now, we're going to solve for A, B, C, D, E, and F. But the way we start is that we look for the one with the highest coefficient. The one with the letter with the highest coefficient, or the variable with the highest coefficient here is D, 12D. So I'm going to assume a value for that D. So let's preferably choose D to be 1. Let D be 1. Let D be equal to 1. If D is 1, let me come up here. The simplest equation here seems to be that involves D is the last one. C is equal to 2D. So that means C is equal to 2 into D. D is 1. So I'm going to put 1 as D. What does that give me? C will now be what? 2. If D is 1, C is 2. C is 2. And if C is 2, let's go to the equation before it. Well, we've gotten C and D, so we can get B from here, from the balanced equation for sulfur. So B plus C is equal to what? 3D. What does that give us? B, that's not known yet, plus, what about C? C is 2. Yes, we've just gotten it here. It's 2. So that's going to be 3D. 3D, that is 3 times 1, because you have presumed your D is 1. So B is going to be, this 3 times 1 is 3. 3 minus 2, B is equal to 1. So we have D, we have C, and we have B. Let's now move on to equation 1 there. A plus 2B is equal to 2E. What would that give? That is A plus 2 into bracket 1, because you've obtained your B to be 1. That's equal to 2E. So A is equal to 2E minus 2. That is our A. Alright, let's keep that somewhere. Let's keep that somewhere so that we don't forget it later. Alright, let me come down to which equation now? Let me come to, for oxygen, this one, this long equation. We have what? 3A plus 4B, but B has been known, so I'll put 4 into 1, 4 multiplying 1, because B is 1. Look at it here. Plus 4C. C also has been known. We got C to be 2, so I'm going to put C as 2 here. So that will be 4 into 2 is equal to 12, and we know we have presumed that D is equal to 1. D is 1, that's it here. So 12 into 1, 12 multiplying 1, plus E. We've not really gotten E. And then, okay. Yes, we've not really gotten E. And then F. Plus F. Yeah, plus F. We have this. And we can move on with this to have 3A plus 4 plus 8 is 12 plus E plus F. This is 3A plus 12 is equal to 12 plus E plus F. Let's bring the letters to one side. 3A minus E minus F is equal to 12 minus 12. Of course, that will become 0. So you have 3A minus E minus F is equal to 0. Good. Good. Now, what is our A? Our A is 2E minus 2. So I will put A to be 2E minus 2. Then minus E, this E, then minus F. Our F is A. You know F is A. Look at it here. A is F. So we put A is 0. So this times this is 6E minus 6 minus E minus A. I'm going to put the value of A again. I've gotten A to be 2E minus 2 here. So let's put 2E minus 2. Okay, it's equal to 0. This represents A. So we have 6E minus E, open this bracket now, minus 2E plus 2, then minus 6 is 0. Okay, let me finish up here. What's going to happen there? 6E minus E, 5E. 5E minus 2E, 3E. So we have 3E minus 4 is 0. So 3E is going to be 4. And our E is going to be 4 over 3. E is going to be 4 over 3. Let's quickly get A. You know we said A is what? Look at it here. A is 2E minus 2. So A is going to be 2 into 4 over 3 minus 2. So that is 8 over 3 minus 2 over 1. LCM is what? LCM is 3. This one goes times 8. That's 8 minus 6. That's A. So our A is going to be 2 over 3. So A is 2 over 3. We've gotten A also. And since A is F, definitely F also must be 2 over 3. A is 2 over 3. F is 2 over 3. I think we've gotten all the letters. This is A. This is B, C, D, and F. So let's compute them now. So we've gotten A to be 2 over 3. We've gotten B to be 1. We've gotten C to be 2. We've gotten D to be 1. And we've gotten E to be, what's E? 4 over 3. And then we've gotten F to be 2 over 3. We've gotten F to be 2 over 3. Now, I want to remove the fractional denominators. So I will multiply every value by the LCM of the denominator. The LCM of 3, and 3 is 3. So I multiply all by 3. So A now becomes 3 into bracket 2 over 3. B becomes 3 into bracket 1, that is 3 multiplying 1. Then C becomes 3 into bracket 2. And then D becomes 3 into bracket 1. And then E becomes 3 into bracket 4 over 3. And then F becomes 3 into bracket 2 over 3. You know, this 3 cancels this 3. So A becomes 2. B is simply 3 times 1, 3. And then C is equal to 3 times 2, 6. And then D is equal to 3 times 1, 3. And then E is equal to, this cancels this, E is 4. And F is 2. F is what? F is 2. F is 2. So these are the values of the letters that we have. These are the values of the letters that we have. So I'm going to put the values here now. I'll put the values here and see whether that balances the equation. Alright, for the A, for this A is 2, so I put 2 here. For this B is 3, I put 3 here. For this C is 6, I put 6. D is here, I'll put 3. E is here, which is this place, that's 4, because E is 4. Then F is 2, this is going to be 2. Now let's check whether the equation is actually balanced. For hydrogen, we have 2 here. 2 times 3 making 6. 2 plus 6, that's 8, making 8, I mean. 8 hydrogen atoms. Let's see here. 4 times 2, 8. It's balanced for hydrogen. Let's go to nitrogen now. This is 2. Just 2 hydrogen atoms. Let's see on this side, on the product side. 2 hydrogen atoms also. So balanced for nitrogen. Let's see for oxygen. This one is 6 for oxygen here. Plus here oxygen is 3 times 4. That's 12. Plus 6 times 4, 6 times 4, that's going to be 24. Everything together, this is 30, this is 42. 42 atoms of oxygen for the product side. Let's see the for the reactant side. Let's see the product side now. This is 4 times 3, 12. 12 times 3, 36 oxygen atoms, plus 4 times 1, that's 4, plus 2 times 1, that's 2. This is 40, 42. This is also 42. So it's also balanced for oxygen. 42 atoms of oxygen on the product side, 42 atoms of oxygen on the reactant side, 42 atoms of oxygen on the product side. Now let's now see sulfur. For sulfur, let me rub up this. For sulfur, we have 3 atoms of sulfur here. We have 6 here. 6 plus 3, making 9 atoms of sulfur. Let's come over here. Sulfur here is 3. 3 times 3, 9. Balanced also for sulfur. Let's now see iron. Iron is 6 atoms of iron. What about this side? 3 times 2, 6 atoms of iron also. So the equation is perfectly balanced, correctly balanced.